Welcome to the new rocket, the Blue Moon. And the Blue Moon is a modular, completely modular with no glue rocket. And if anybody don't know what a blue moon is, it's the third moon in a calendar month that has 4 moons. Why the fourth one is, I don't know. I'm not a moon expert. The rocket is 47 inches long. I'm going to round off here. 47 inches long. It's got 647 grams of weight. With a PVC G120 that I tested the other day, it's stability of 3.12, and the center of gravity is 32, and the center pressure is 39. With a G120, it's doing 92.7 foot per second off the rod, with an apogee of 1027. And the detached lower section with a side streamer, because I got tall grass here, is the drogue, and then an 18-inch parachute deployed at the program altitude. The flight computer is a DDD 1500 dual deploy, and the engine is a rotary rocketry Dart Monkey with a few modifications to it. It's got a PLA insert for the washer holder that's put in, and then it's molded and broken off, and it leaves a little bit of PLA in there. And the top of the motor has a PLA washer or disc to help find the top of the motor quickly, because some of these lightly loaded ones, you know, they're nowhere close to the top. So what's new about it? The length of it. This, in comparison to the Phoenix, the one we did before. It is longer. It's got different fins on it. This is a fin that's not so swept back, but it does give a good stability of 3. The middle joiner, also known as the eBay, is completely different. It's got a different closure on it for adding the battery. The battery is internal instead of hanging out the side of it. And the nose cone is new. And the rail guide pins are new. They're fastened on with screws now and no glue. So the whole effort of the thing was to make a rocket that is completely modular. Any piece can go bad and it can be replaced and keep the rest of the rocket. A broken fin is easy as putting a new one in there. And on the fin itself, the CNC cuts this blue moon writing in the moon here, but it's hard to get it all uniformly black without getting some of the letters black. So I gave up on that. I'm still going to cut the design. It'll be on one side. On the other side, I do a 3D printed blue moon plate, and it is just glued on there. So if it had to be replaced, it could be snapped off. If the fin broke and the fin had to be replaced, it could be snapped off and put on the new fin with a little bit of glue. There's not much because it's such a flat surface. A little bit of glue holds it greatly, and I believe that is the only place that there's glue on the entire rocket. So we'll do a little quick view of the thing. You can see the nose cone there. And then we come down to the air hole where the sensor can pick up the altitude. It's a 20 millimeter hole. A little bit of reflective tape here, hopefully to get a little shine out of a 1,000 foot launch. And then the 2 rail guides that are attached with 2 screws. And they're all on the lower section, so there's no line in the upper and lower section as it's getting ready to be flown. There's also the 2 rail guides here on the bottom, but somewhere along the way they got fat, and the new one doesn't have but 1 on it. The problem is, like with this rail guide here, you can see that the end is broke off. Well, it was a simple fix. I was printing it with this being the bottom, and a little bit of support material on the very tip. So I just flipped it over and started printing it with the big end on the bottom, and that cured that problem. Because it would have support material there, and then when I tried to get it off, it'd break the tip out of it. That's like trying to see yourself in two mirrors, you know? No matter which way I move that rocket, it don't work out. The upper part here is reinforced with these ribs. I had a lot of breakage occurring right here. If the parachute didn't deploy, it would break right there almost every time. So I reinforced this, raised it up a little bit, thickened it some. And there's the same 2-screw pattern to attach the fins, one on each side, and then the same on the other side. So what I'm going to do now is I'm going to disassemble this thing and talk about more of the internal parts. So to do that, I got to take some screws out. I made one video and I just didn't like it. There's just too many things that I wasn't liking about it. So after that video, I went ahead and put it completely together, almost ready to fly. So now I'm having to backtrack and lift my cap over again. Now I did something it kind of wound up good by accident. See if I can show it here. There's an opening right there. And what that's opening for right here is the when you tie the cord, the shock cord to this tube, that post that sticks up, it's got a hole in it, and it gets support material in there. So to get it out, there's not, I guess you could use like a Allen wrench maybe, but it's hard to push from the side. So I just put a little hole in it to be able to push through that post. And then the added benefit is it works great as an alignment site to get the 3 screw holes lined up. But like I said, this thing here is completely removable, and inside there is the I call it a sight streamer. It's really not going to slow the rocket down at all hardly, but we got tall grass here now, and it's getting hard to find the rocket if the parachute doesn't fully deploy and hang up in the top of the grass. So then here we got these are attached. I'm not going to take them off, you know, they're just bands that fit on there. The center section is where the eBay is, and it is completely attached to the upper section of the rocket. And I was smart this time. Before I cut the tube, I put a mark down the tube where it was going to be cut. And so that works great to get the alignment back correct on the tube, because I did a little divot right there and a little dragon's tooth beside it, and so those two things have to match up really well to be able to have a complete body tube with no gaps in it. It's just appearance, that's all it is. So then to fly, this is the wire going to the drogue ejection charge, and this is the Kevlar cable, 600 pound, going down to this bottom fin section. So to get ready to fly, one just takes this off. It's now screw on, so I don't have to mess with 2 screws. And the battery is internal instead of external. Gives it a little more protection. And then on the upper end, you got the, I'm not even going to take that out this time. Yeah, I will, because it's got the stupid tube on there, the attachment point. I only got 1 screw in this one. That's what I got to do, is put the two more screws in here before I fly. I'm going to do myself a favor. When I did it yesterday, I had a heck of a time getting that 1 screw hole lined up. So what I like to do is I like to do a bottom marker to know how deep it's going to go. This is going to go in it, and then put me an alignment line. So it winds up being a T to an I. So what is that? Crossing your T's and dotting your I's? Something like that. So now we can pull this thing out. It would never come out unless you're doing some repair or replacing this cable because it got consumed. You know, but the black computer is in here, and the other one, the Phoenix, had a like a T-post on it, which it made a loop and then it couldn't come back off. But you know, as I make things, I try to make them better and more secure. I mean, it could come off, and I just don't want to have to worry about that. These two holes where the wire and the cord goes through, and where they come out, I put a little piece of aluminum tape over it to keep any kind of gases, discharge gases, from getting up in there. And then this is the upper stroke. I've started using this. I'm going to switch back to shell casings, like a AK, what are they, .3947, whatever they are. Anyway, and then put a little piece of tape over it. It gives a little more push. The powder's contained just enough to force it out in one direction. And then the nose cone is new, which the only change of it is really there's no change other than the appearance is longer. And then you got this big bar here across the bottom that supports the shock cord. And I attach the parachute right to the nose cone. It seems to work better for me that way. And this one has ribbing on the nose cone to kind of simulate a rocket that would open up like an onion and deploy small satellites. So that's what that is. It's a little heavy, but I like heavy. It adds a little stability to the rocket with being heavy up on the front end of it. And moving the flight computer, I initially made it the other way around where the fins would have been attached here. So by doing it this way, the flight computer is further up towards your nose, which adds stability. And this part is still adaptable to 3 engines. If I want to fly commercial at one of our club lunches, I would use this and put the commercial engine in there, a couple of screws to hold it in place, and then the engine goes in there with no ejection charter. And then it can fly the Dark Monkey's ceramic only engine that Rotary Rocketry made. They used, I believe it was 8 lugs. I put 10 on there. There's one every 36 degrees all the way around it to give 10 lugs. A little better retaining. The rings are consumables, but I will reuse them if I can, if I don't wind up getting lost. And they're just to keep the motor centered in there because it's way too little. That wouldn't work. You see, put this in there and then bring it up there and lock it in place. There would be some tape on it to make it more secure. But I mean, if you lose the engine, right, other than falling on somebody, there's no big issue with it. These style engines, I still put a little bit of rockweed in the top just as a fire protector because I've seen some that so that works real well. It only adds a gram or 2, maybe 10 grams. And this is the original Dark Monkey that George makes over at Rotary Rocketry, and it's a very reliable engine. You don't have to worry about losing an end cap. You got a ceramic piece here holding a 1864 washer, for me, 1864 washer in the bottom, I think he uses a 1964. The 18 just gives a little extra thrust, and then the top has got a little bit of ceramic in the very top of it, but basically it's just glued on there. And the disc is in there to find the top of the engine. So that is a tour of the Blue Moon. I will include the ORK file, the rocket file, design file, and also these components, these parts, the badge, the ring, the adapter, the eBay, and the nose cone, so that if you want to build one, you can print them out in your favorite color. The body tube is one 34-inch, one solid 34-inch BT70H heavy duty, and then it's cut at the 12-inch mark. So 12 inches is the upper parachute. The remaining 22 or whatever it is the bottom where the fins are attached. And then as far as the rocket design, you know, the fin can adds, 9 inches, no, not because it's bottomed out. So it adds about 5 inches to the length of the body tube, and then it adds another 5 inches or so to the length of the rocket, because the fins are swept down instead of straight out. Now, fin, the further it sticks out, the more drag you got, but the more stability you get to a certain point. I mean, you can go crazy with anything, right? And so this rocket flies very well. I've flown one on a very weak engine just to see how the stability was when it's not straight up and out of sight. I just kind of lumbered up to the 200 feet mark, and it stayed on a straight line. It did good stability. Excuse me. All right, well, so that wraps it up. Hope you've learned something out of it. Hope you enjoy building a rocket if you decide to build it. And if you want to build it just to fly, you know, commercial engines, I would redesign. If that's all I was going to do, I'd redesign this fin can where you got to have a paper tube in there. You can't have PLA against a burning engine; it'll melt it. But you do the like this one is a PLA on the outside, and then it's got a regular engine tube on the inside. That's just to keep the hot engine off of the PLA, and also to give it, you know, obviously some support all the way up. But I would redesign it where this thing was not needed. If I was going to fly just Aerotech 24 or 29 millimeter engines, I would design this piece where it accepted the engine straight on without the adapter. But I like to fly, you know, here and there, and can't fly shorter rocket at a NRA club launch. And certain restrictions apply at AAA, I believe, as well. Alright guys, that's the end of it. Thank you for looking at it, and we'll see you next time.